Hi guys, so today we'll be solving this problem called spiral matrix. Let's understand what we need to do here. So for example, let's take a 3 cross 3 matrix and we have numbers as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So we've been given this matrix and we need to print it in a spiral form. So a spiral form, what I mean by that is that we need to go here first. We need to, we need to come down, need to go here, we need to go up, then we need to go here. Okay. So in this order, we would print 1, 2, 3. Then we need to come down. So 4, 5. All right, and then go left, which is 6, 7, and go up, which is 8, and then go right, 9. Okay, so in this form we need to print the matrix. So how we can solve this problem is by we understand that we need to go from left to right and then from top to bottom, right? So what if we keep 4 pointers? So what if we keep a pointer here, which is top, we keep a pointer here, which is down, okay, and we keep a pointer here which is left, and we keep a pointer here which is right, and we try to see what how we can traverse through these pointers by using these pointers. So first of all, we know that we need to go from left to right. In every matrix we need to go from left end to the right end. So what we do here is that we take the top pointer and we move from left to right by using these two. Okay, so we'll maintain a I which will be going from left to right, and we simply will be printing out the matrix. So say for example, this matrix is called A of M and N. So matrix of A of top, which remains as it is, and I is variable which is from left to right. Okay, so this will print the order which is from left to right, which is 1, 2, 3. Okay, now we understand that we need to come from top to bottom, and what is constant here? The right pointer would be the constant. All right, so here we'll be going from, let me just write it down. We'll be going, so this is the first step, this is the second step, which is now the variable would be from top to bottom, right? We are coming from top to bottom. So I will be equal to top to bottom, and we'll be having the matrix traversing from top to bottom. So we need to keep the constant as right. So A will be uh, I and right. Okay, so I will be variable which will be moving from top to bottom, and right is kept constant because we are going to the right, the extreme right, and printing the order from top to bottom. All right, and then now we understand that we covered this part, we covered this part. Now we are here. All right, so at this place, we know that we need to go to the left. So the third step would be I will be from right to left. Okay, from right to left, and we have constant as down. All right, so at this time we'll be printing A of down, and I will be variable from which will be right to left. All right, and then now we come here. So we know that here, from here we need to go up. All right, so for this we have this fourth step, which is I is equal to down to top, and we will be printing I, and the constant would be left because it's the extreme left, right? So A of left. Now we've reached here. Okay, all right, now we understand that, okay, now we need to go inside the matrix, right? So for this, we'll be doing one trick, which is that after every step, 1, 2, 3, and 4, we'll be, doing some operations which will help us, get the matrix from left to right, and also traverse ahead and move a pointer ahead to go inside the level. Okay, so for example, this is the level 1. Okay, and this is the level 2. So going inside the level 2, what we do is that, first of all, when we have the top operation, we increase the top. Okay, so top would, we'll be doing top plus 1, so top will be coming here. Okay, top will be coming here. And then what we do is that whenever we do the second operation, which at which the right is constant, right? So at that time we'll be moving right to the left, so it would be coming right, right would be coming here. Okay, now when we go to the down, now down is constant, so we do down, minus minus, so down would be coming here. Okay, and when we have left, we do left plus plus, which is left would be coming here. Okay, so when we are here, we know that only thing that is left to print is here. So we will be moving from left to right, which is at this place only, which is at this row. Okay, at this column we are gonna print 9, and we'll be moving from uh, left to right, which is only having element 9. So therefore we would be able to print left, we'll be able to print 9. Okay, so this is the algorithm that we need to follow. And we'll also be maintaining a direction to make sure that we are going in a particular direction, which is, as we said, step 1 is going from left to right, step 2 is coming from top to bottom, step 3 is going from right to left, and step 4 is going from top to top or down to top. So for this we need to maintain a counter which will tell us which direction to go to. So let me write a counter, let me call it direction, and direction plus 1 will give us, we'll be initializing direction to 0, and at every step we'll know where to go according to the direction. Let me write %4 so that we come back to 1 2 3 4, and we maintain that order. So okay, here we will be maintaining 0 1 2 and then 3, because if we are doing %4, then we need to start from 0. Otherwise, if you are doing %5, that doesn't make sense. Let's do it %4, because we need to start from 0 1 2 3. Okay, these were the 4 steps that we need to follow, which gives us the direction in which we need to follow the algorithm to go to. Okay, and yes, that's it. That's what we need to do. Let's get to the coding part, and it will be more clear to you. So in this problem, we'll be, first of all, we need to return it in a vector form. So we'll be maintaining a vector, and let me write vector int answer. Okay, now let's make the variables, let's make the 4 pointers, which is top is equal to 0, right down is equal to matrix. Let me just name this a. Okay, because we used a there. So a dot size minus 1, right is equal to uh, first of all left equal to 0, and right equal to a dot size minus 1, a of 0 dot size. Okay, so we've initialized the 4 pointers. We'll be maintaining a direction too, so direction is equal to 0, and then we have what do you call, what's left. um yeah, I think that should be good to go for us to make the conditions. So first of all, we'll be checking if top is less than down, and left is less than right. So this will be the condition for while loop. Then we'll be checking, first of all, if the direction is equal to 0 at that time. Okay, we need to also maintain the pointer, as I told you, I for going for the traversal. So for I is equal to, first of all, first step was to go from left to right. So I is equal to left, I is less than equal to right, I plus plus. At this time, we'll be pushing A of top and I. Okay. And as I told you, we need to also do top plus plus, which is going a step ahead in top. Okay, so that we get all the orders in the matrix. Then we check if direction is equal to 1 at this time. So we've gone from left to right, now we come from top to bottom. So at this time, for I is equal to top, I is less than equal to down, I plus plus, and answer dot push back A of I, and what is the constant there? Right. Okay. And what we do here is that down, uh, at this time we do what we are on the right side. So at this time we do right minus minus because we need to come inside, right? So at this time we do right minus minus. And then else if direction is equal to 2, at this time we run a for loop, and um, we are at the bottom. So at the bottom, we need to go from right to left, right? So right I is greater than equal to left, I minus minus, and answer dot push back. And we will be making A of down because we are at the down, and I is the constant. And we'll be doing down plus plus. Okay. Now we come to the last one, which is 3. At this time, we'll be going from down to top. So I is equal to down, I is greater than equal to top, I minus minus, answer dot push back A of uh, I, and we are at the extreme left. So left, and we do left plus plus, which is going ahead. Now we come out of this and we maintain the direction, which is, as I told you, direction is equal to direction plus 1 and %4, and we return answer at the end. Okay. And yeah, that's what we need to do here, as we followed every step, which is going from left to right, then top to bottom, then right to left, and bottom to top. Okay, so let's run the code to see if everything is working fine. Okay, what error do we have? Runtime error, misaligned address, just 4-byte alignment. So we are going at a place where we don't need to go here. So left plus plus and down minus minus would be there because we are going up, right? So down minus minus. Yeah, that works fine. And that is accepted. So I hope you guys understood the problem. Do solve it and do like the video and subscribe to the channel. And yes, thank you. Bye.